Have you ever stood on the shore and wondered what truly lies beyond the horizon where the sky meets the sea? In the modern era, the ocean is no longer just a highway for trade, but a high-stakes arena of engineering where the boldest designs claim the greatest rewards. Hello to all of you. As we speak today in May 2026, the global maritime landscape is shifting beneath our feet in ways that few could have predicted a decade ago. Today, we begin an in-depth exploration of the colossal vessels that are currently redefining what is possible on the open water. Focusing on the first two giants in our countdown, we are looking at how these developments impact our global understanding of geography and energy. Our journey begins with number 10, the Shiyou 2, a vessel that has fundamentally altered the conversation around polar exploration. For many years, we in the United States have looked to our heavy icebreakers like the Polar Star as the ultimate symbols of Arctic endurance. However, the Shiyou 2 represents a new philosophy in ship design. This is the first domestically built Chinese icebreaker, and it features a groundbreaking dual-direction ice-braking system. While traditional ships struggle when they lose forward momentum, the Shiyou 2 can pivot and use its stern to crush ice that is over 4.9 feet thick. With a displacement of nearly 14,300 tons and a length of 398 feet, this ship is a literal floating city of science. When we compare this to the United States Coast Guard's current fleet, we see a clear move toward high-tech specialized research capabilities. This ship is designed to operate in temperatures as low as -40 degrees Fahrenheit, providing a stable platform for deep-sea surveying and atmospheric research in the most hostile environments on our planet. It is a testament to how modern materials and hull geometry can conquer the frozen frontiers that once stopped explorers in their tracks. It serves as a reminder that the poles are no longer unreachable. Moving from the frozen north to the deep waters of the South China Sea, we encounter number 9, the CNOOC 981. To call this a drilling rig would be an understatement. It is a 6th-generation ultra-deep-water semi-submersible platform that stands as a marvel of structural engineering. Imagine a structure as large as a standard American football field, rising 40 stories into the air. This platform is engineered to operate in water depths of up to 10,000 feet, and can drill to a total depth of nearly 30,000 feet into the Earth's crust. In the United States, we have long been the leaders in deepwater technology in the Gulf of Mexico, but the arrival of the 981 signals a significant closing of the technological gap. One of its most impressive features is its ability to remain perfectly stationary using a world-class dynamic positioning system, even when facing waves as high as 50 feet. This level of stability is crucial for ensuring safety and environmental protection during complex drilling operations. By integrating advanced sensors and automated control systems, this platform can extract resources from the most challenging underwater terrains. As we look at these two vessels together, we see a clear strategy of mastering extreme environments. Whether it is the crushing pressure of the deep ocean or the relentless ice of the poles, these machines are the new sentinels of the sea. Pushing the boundaries of what we once thought was impossible, the world is watching. Continuing our journey through the titans of the sea, we move into a realm where raw industrial power meets the relentless forces of nature. As we look at the next two vessels in our analysis, we see a fascinating intersection of logistical necessity and extreme durability. In the United States, we have always valued the concept of heavy duty, and these next examples embody that spirit on a scale that is difficult to visualize without seeing them in person. We are moving from the specialized frontiers of the poles and deep-sea drilling into the very heart of industrial construction and offshore resilience. Coming in at number 8 is the Hongchi gang, a vessel that can best be described as an industrial titan. To understand the scale of this ship, one must envision a floating platform specifically designed to carry the heaviest components ever manufactured by human hands. This is not a container ship. It is a heavy-lift vessel that functions as a mobile foundation for massive infrastructure projects. With a length of over 520 feet and a width of approximately 130 feet, The Hongchi gang is built to transport prefabricated bridge sections, giant wind turbine components, and massive industrial modules that would be impossible to move via traditional land routes. In American engineering terms, this is the equivalent of a heavy-haul flatbed truck scaled up to the size of a city block. What makes this ship truly remarkable is its ballasting system. To load these gargantuan items, the ship can submerge its deck below the waterline, allowing cargo to be floated over it before the ship rises back up, lifting thousands of tons out of the water. This roll-on, roll-off, or float-on, float-off capability is essential for modern modular construction. We are seeing a shift where instead of building a bridge or a power plant on site at the coast, entire sections are built in a controlled factory environment and then delivered by vessels like the Hongchi gang. This method significantly reduces construction time and increases the precision of the final structure, a technique that we also utilize in our large-scale civil engineering projects across the United States. While the Hongchi gang handles the heavy lifting, our number 7 vessel, the Haiyang Shiyou 982, is built to face the ocean's fury. If the CNOOC 981 we discussed earlier is the pioneer, then the 982 is the veteran warrior of the storm. This is a deep-water, semi-submersible drilling platform specifically engineered to operate in the volatile environments where typhoons are a frequent and deadly reality. Standing on 4 massive columns, this platform has a displacement of over 30,000 tons. When a storm approaches in the open ocean, most vessels seek harbor, but the 982 is designed to stand its ground. It is equipped with a state-of-the-art thruster system and a sophisticated mooring arrangement that allows it to maintain its position even when subjected to wind speeds exceeding 100 miles per hour. In the American energy sector, we understand the immense cost of downtime during hurricane seasons in the Gulf. Therefore, the engineering focus here is on survivability. The deck of the 982 is a maze of automated drilling equipment, reducing the need for personnel to be exposed to dangerous conditions. Every sensor on this platform is fed into a centralized computer system that can adjust the platform's buoyancy and orientation in real time. This ensures that the drill string remains stable even as the hull beneath it is buffeted by massive waves. It represents a level of technical maturity where the goal is no longer just to reach the oil, but to do so with a level of reliability that minimizes environmental risk and maximizes operational efficiency. As we observe these 2 vessels, we see a clear picture of how modern maritime technology is being used to overcome the physical limits of our world. One moves the unmovable, while the other stands against the unstoppable. Together, they represent a significant step forward in the ability to build and operate in the most demanding marine environments on the planet. As we move deeper into the heart of our list, we find ourselves at the intersection of global trade and the hidden treasures of the deep ocean. These next 2 vessels represent a significant leap in how humanity interacts with the sea, not just as a surface to be crossed, but as a source of immense wealth and a vital artery for the world's economy. In the United States, we have long understood that he who controls the sea lanes and the technology to harvest the seabed holds the keys to future prosperity. Today, we are seeing a new chapter in that story being written with incredible precision. Ranking at number 6 is the Haiyang, a vessel that looks like something out of a science fiction novel, yet its mission is very much grounded in the reality of our future resource needs. This is a highly specialized deep-sea research and mining vessel designed to explore the mysterious abyssal plains of the ocean floor, which can be over 18,000 feet deep. The Haiyang is equipped with a suite of advanced sonar systems and remotely operated vehicles that can map the seabed with centimeter-level accuracy. What makes this ship so critical is its focus on polymetallic nodules, small rocks found on the ocean floor that are rich in cobalt, nickel, and manganese. For those of us following the transition to green energy in the United States, we know these minerals are the lifeblood of electric vehicle batteries and renewable energy storage. This ship is essentially a high-tech scout, finding the materials that will power the 21st century. It features a silent propulsion system to avoid disturbing the sensitive marine environment while it works, and its laboratory facilities allow scientists to analyze samples in real time without ever returning to shore. The level of automation on board is staggering, with computers managing the deployment of heavy equipment and pressures that would crush a conventional submarine. We are looking at a vessel that represents a long-term investment in the supply chains of tomorrow. While the Haiyang searches for what is beneath the waves, our number 5 vessel, the COSCO shipping universe, dominates everything on top of them. This is a true giant of the blue economy. When we talk about the scale of global trade, this ship is the definitive visual aid. The COSCO shipping universe is one of the largest container ships in the world, with a length of nearly 1,312 feet, roughly the height of the Empire State Building if it were laid on its side. It has a staggering capacity of over 21,221 standard 20-foot containers. To put that in perspective, a single voyage of this ship can carry enough electronics, clothing, and household goods to fill thousands of American retail stores. In the United States, our major ports in Los Angeles and Savannah are constantly upgrading to handle giants like this, because the efficiency they bring is what keeps consumer prices stable. The universe is not just about size, however, it is a marvel of hydrodynamic efficiency. Its hull is coated with advanced polymers to reduce friction, and its massive engines are designed to optimize fuel consumption, reducing the carbon footprint per container to levels that were previously unattainable. This vessel is a physical manifestation of the interconnectedness of our modern world. It links continents in a matter of weeks, moving the vast majority of products we use in our daily lives. As we analyze these two ships, we see a dual strategy at play. One vessel is securing the raw materials for future technology, while the other is perfecting the delivery system that brings that technology to your doorstep. They represent the two halves of a global machine that never stops moving. It raises some fascinating questions about the future of our oceans and how we balance our need for resources with our responsibility to protect the environment. I would love to hear your thoughts on this. With the rise of massive mining ships like the Haiyang, do you believe the deep ocean will become the next great frontier for the global economy, or should we be cautious about disturbing these untouched ecosystems? Also, when you see a giant like the COSCO shipping universe, does it make you think differently about where the products in your home come from? Please share your opinions and insights in the comments below. We always value the perspective of our experienced audience. Moving into the upper echelon of our list, we enter the territory where maritime engineering serves as a powerful symbol of national ambition and structural mastery. The next two vessels represent the pinnacle of two very different but equally vital fields: the projection of maritime influence and the physical construction of a connected world. In the United States, we have a storied history of naval excellence and massive infrastructure projects, from our legendary carrier strike groups to the great bridges that span our bays. Seeing these advancements abroad allows us to appreciate the sheer scale of modern global engineering and the precision required to execute such projects. At number 4, we have the Type 003 Fujian, a vessel that marks a historic turning point in naval architecture. This is not merely a larger ship, it is a technological leap, displacing over 80,000 tons and stretching more than 1,000 feet in length. The Fujian is the first ship in its class to utilize an electromagnetic aircraft launch system, or EMALS. For decades, the United States Navy's Ford-class carriers were the only vessels in the world to employ this sophisticated technology, which replaces traditional steam catapults with powerful electromagnetic force. This allows for a smoother, more efficient launch process, enabling the ship to handle a wider variety of aircraft, from heavy fighter jets to lightweight unmanned drones, with significantly less wear and tear on the airframes. The complexity of the power systems required to charge these catapults in a matter of seconds is immense, requiring a massive electrical grid within the ship itself. For those of us who appreciate the nuances of maritime power, the Fujian represents a move toward a flat-top design that prioritizes high-tempo flight operations and modern radar integration. It is a vessel designed for the digital age, where data links and electronic warfare are just as important as the steel of the hull. We are observing a shift from traditional designs toward a future of integrated, high-tech naval platforms that serve as floating command centers. While the Fujian projects influence across the horizon, our number 3 vessel, the Zhenhua 30, is busy building the foundations of the future right at the water's edge. This is the world's largest self-propelled single-arm hook crane ship, and its capabilities are truly breathtaking. Imagine a crane capable of lifting 12,000 metric tons, the equivalent of about 60 blue whales in a single move. The Zhenhua 30 was the primary tool used in the construction of the Hong Kong-Zhuhai-Macau Bridge, the longest sea-crossing bridge in the world. Its role was to lift and precisely place massive 6,000-ton tunnel sections into the seabed with a margin of error measured in millimeters. This level of precision on the open sea, where currents and winds are constantly shifting, is a feat of engineering that demands the utmost respect. The ship itself is over 970 feet long and features a sophisticated dynamic positioning system to keep it perfectly still during these critical maneuvers. In the American context, we can compare this to the massive equipment used to maintain our own vital shipping lanes and coastal bridges, though the sheer lifting capacity of the Zhenhua 30 puts it in a class of its own. It is a reminder that to build the impossible, you first have to build the machines that can handle the weight. Analyzing these two giants together, we see a focus on both strength and precision. One vessel is built to launch the fastest aircraft into the sky, while the other is built to lay the heaviest foundations beneath the waves. They are the architects of the modern maritime era, one ensuring security and the other ensuring connectivity. Both reflect a deep commitment to mastering the technical challenges of the sea. As we prepare to move into the final 2 positions on our list, the scale of these achievements only continues to grow, showing us a world that is becoming more integrated and technologically advanced every day. We have finally reached the summit of our countdown, where the most ambitious visions of maritime engineering come to life. These final 2 entries are not just ships, they are catalysts for a total transformation in how we perceive global logistics and energy independence. In the United States, we have always been pioneers of the big idea, and seeing these concepts realized on such a massive scale is a testament to the boundless potential of modern science when applied to the vastness of our oceans. We are witnessing the dawn of an era where the sea provides not just a path for travel, but the very power that sustains our civilization. Standing at number 2 is the COSCO shipping galaxy, a titan that has effectively rewritten the rules of global trade. If the Universe-class vessels we discussed earlier were the pioneers of size, the Galaxy is the master of efficiency and refined capacity. With a length of nearly 1,400 feet and a capacity to carry over 21,000 standard containers, this vessel is a vital organ in the body of global commerce. However, what truly distinguishes the Galaxy is its commitment to smart shipping. It is equipped with an incredibly advanced hull-air lubrication system. This technology creates a thin layer of bubbles beneath the ship, reducing friction against the water as it moves. In American maritime circles, we have studied this technology for years as a way to slash fuel consumption and carbon emissions. By reducing drag, the Galaxy can maintain high speeds while using significantly less energy than traditional vessels of its size. The interior of the ship is a marvel of automation, with a centralized brain that monitors everything from engine temperature to the exact weight distribution of every container on board. This ensures maximum stability and safety, even when navigating the treacherous waters of the North Atlantic or the crowded straits of Southeast Asia. The Galaxy represents a shift toward a more sustainable and data-driven shipping industry, where every voyage is optimized by artificial intelligence to ensure that goods reach their destination as quickly and cleanly as possible. Finally, we arrive at number 1, a project that sounds like it belongs in the future, but is very much a reality of today: China's floating nuclear power plant. This is perhaps the most significant maritime development of our time. Imagine a massive, rugged vessel that carries a modular nuclear reactor capable of sailing to remote islands coastal cities, or offshore oil rigs to provide a constant, carbon-free source of electricity. For those of us in the United States who have followed the development of small modular reactors, this is the ultimate application of that technology. These floating powerhouses are designed to be incredibly resilient, built to withstand extreme maritime conditions and even seismic events that might threaten a land-based plant. By placing the reactor on a floating platform, the ocean itself acts as a natural heat sink, providing an endless supply of cooling water. This vessel can provide power to areas that are otherwise cut off from the national grid, supporting everything from desalination plants to deep-sea mining operations. It represents a total decoupling of energy production from geography. No longer is a city or an industrial site limited by its proximity to coal mines or gas pipelines. Now, the power can simply sail to where it is needed most. This is a profound shift in how we think about infrastructure, moving from static, permanent buildings to mobile, adaptable assets that can respond to the changing needs of a nation. As we conclude this deep dive into these 10 maritime marvels, we are left with a picture of a world that is rapidly evolving. We have seen ships that can crush through miles of ice, platforms that can stand firm in the heart of a typhoon, and now, vessels that carry the power of the atom to the farthest corners of the Earth. These achievements highlight a global drive toward mastering the most difficult environments on our planet. Looking back at this list, which of these vessels do you believe will have the greatest impact on our daily lives in the coming decade? Is it the massive container ships like the Galaxy that keep our stores stocked? Or is it the revolutionary idea of a floating nuclear power plant that could change how we fuel our world? We are living in a time of incredible transition, and your perspective on these technological shifts is vital. Please share your thoughts and join the conversation in the comments below. I look forward to reading your insights and discussing the future of our oceans together.